Hello everyone, Patrick here. Today we're going to be looking at the Spotlight object, and we're going to be using it to build a more complex scene and take a look at all the different options that are available to the Spotlight. So without further ado, I'm going to show you the scene that I've kind of built up right here. You can see what it's demoing is a Spotlight, as well as three different other objects in the scene. A Hello World text object, a cube, and this torus knot as well. So what we're going to do, as opposed to just writing up all the code itself, is we're going to actually go through each of these, the little bits of code right here, line by line, and take a look at that. And then once we're done understanding how that's built, we're going to take a look at this little controller and see how the light object works in the scene. So let's go over the scene first. First, we have our variables that are going to be shared amongst all of the different functions. Now, in the past, we've kind of made everything go into the render animation function down here when we've changed things. Now we're going to start separating things into more complex functions so we can keep things kind of compartmentalized. Right here, what you're looking at is our initialization function. And this kind of initializes all of these different variables that are shared everywhere else. And then we have our render function. And this is going to render our scene, and then our request animation function. So essentially what this is going to do is keep repeating the action, but do it efficiently, so when you do minimize the screen, this animation stops working at that point. Alright, so let's go through this all line by line. Alright, so we have first our scene variables. Scene camera renderer. Alright, then we have our control variables for our GUI. Okay, so that's right here. This is the GUI. These are the GUI controls. And then this one right here are the orbit controls for actually moving about the scene. And I'm using a separate library included within the THREE.js in order to do these orbit controls. And that's right here. Orbit controls, and that can be found under Mr. Dube's JS under the lib folder under examples, the orbit controls. In order to run that, all you have to do is create a variable that's a new object for that, and then you're going to want to add an event listener that affects the screen itself. Very, very simple and easy to call, just these two lines. Alright, so that's the controls. Next, we have our axes helper, our grid helper, and that color object that we assigned to the grid that we created earlier. All right, next we have four geometries within the scene. Cube geometry, this one right here. The torn knot geometry, torn knot. Text geometry, right here, that's our hello world, and our plane geometry. And you can see those are all getting called in order right down here. Next, we have the materials for each of those, and you can see those are all getting called. There's our cube material getting called, text material, and plane material all getting called. And then finally, the objects themselves. Torn knot, torus knot, text, and plane. And you can take a look at how those are getting called. So we have our geometry right here. That's the new geometry. Then we have the material right here, the mesh lambert. And then we have the object that's that combines them both as the geometry and the material to create the plane itself. All right, so you can see as well we're adding to the scene those axes helpers, along with adding to the scene the grid, and so on. And that's how we're creating that. Now we're going ahead in here and assigning the position for each of these objects. So the cube is located at 2.54, 2.5, and we're having it allowing it to cast a shadow. Next, we're assigning the position of the torn knot, which is located at -15 on the x-axis. And again, you can look at the axis helper right here to define those locations. And then 6 and 7, cast shadow equals true again. Finally, we have our initial camera position. If I hit refresh on here, you'll see the initial camera position on there. All right, and we're telling it to look at scene position. All right, next we're adding our GUI object that controls everything. And you can see that's a function that we've added that contains all this information. Okay, I'm using this command right here that just basically means that GUI controls dot rotation x is being referenced in this kind of control object. So anything where you see this, it's really just referencing that. So later, when I say GUI controls dot intensity, that's the same thing as this dot intensity equals 1. So when we initialize the starting variables for here, we're just referencing this object right here. All right, so you can take a look through all that. All right, next we're adding these all to the scene. So basically we've initialized these objects, but what we need to do is just add them to the scene to allow a person to manipulate them. And we're doing so with these. So we're doing DAT GUI, that's the initial GUI construct object, dot add, GUI controls, and then the name of it that we're referencing, which is located up here. So rotation X. And then we're setting the values that it can be in between. So you'll notice if I shift these values now, it goes all the way up to 1. Okay? And that's how you initialize those starting values. All right, now these are being initialized through the request animation scene, or updating through here in this render function. So everything's up, these guys are updating through there, along with these position is updating through there. So I haven't done an onChange function up here. Now I do call an onChange function for some of the other controls. All right, so you can see what I've done here is I've added a array right here of cube, torus knot, and test. Okay? And then I'm saying that onChange this array, which is this object right here, if it's the cube, the target equals the cube. Now if we hop through this THREE.js documentation, you'll see that we have a target value and the default position is 0, 0. So the spotlight focuses the position at target position. Now what it doesn't say in here is that that target needs to be an object for it to work. If you try and assign a position value to it, it's not going to work. You need to assign it an object for it to work. So I've gone ahead in here and assigned it initial value of cube, but now we can go and change that to torknot or text. And you can see it repositions the light given those values. Okay, and that's how I've done that. All I've done is said onChange right here, call this function, and this function is if it's equal to a cube, it changes the target to the cube. Very simple. All right, so then with these, I've done an onChange function. If the intensity changes up here, and it's listening for that with this onChange function that's part of the DAT GUI, then the intensity, then the value, which is this one right here, that value is now this one, spotlight.intensity. And I called all those spotlight.intensity in here, and I changed all those variables already to the initial values that we initialized when we started this. So our spotlight begins with all these initial values. And again, you can look at all of those different ones right over here. All right, so all of these functions are listening for changes. Now the big ones I want to show you though are some of these other things like this shadow map right here that tells you essentially the positioning. It's a little helper that tells you the exact positioning of this light. Now you'll notice that I can change the field of view, the far clipping on this, and the near clipping, and the position on it. And you'll see that this little helper right here changes, and according to that. Now, if you don't have shadow camera enabled with an update projection update projection matrix, this is not, you're not going to notice any changes. So if I removed this from here, you would not see this move around. You would see it stick with its default values from what you set when you originally ran the scene. So it's really important that you actually update this if you are using this right here. And again, that's not really listed in the documentation right over here. So it's just something that you have to be aware of. I've also not added the shadow map height and the shadow map width. The reason being is that that is a value that's assigned when you initially refresh the screen. So with adding that down here as a variable that you can play with, you're not going to notice any difference between it. But again, feel free to take a look through this code, and I will provide it for you at the end in the links on the description. So feel free to look through everything here, and you can kind of get a better idea of what each and every single one of these does. All right, so next thing what I've done is I've added a stats, so I could actually check out the frames per second, and you can see it's actually rendering very, very smoothly. It's it's not very complicated of a scene, but you can see I'm getting probably close to 60 frames per second, and this is all running off of the GPU in my computer. I've tested this on a mobile device, and it runs equally as fast on that. It's a pretty fairly streamlined little animation right here. All right, so what I'm doing right here is I'm starting a new stats. Again, it's another library function that's included in the THREE.js. And the other thing I'm doing is I'm adding just a little bit of styling and just plopping it directly onto the DOM. So I'm taking that, I'm saying the stats, and referencing the DOM element, telling the style position is absolute. And this is, again, this is a CSS reference. So absolute means it's always in that position. And I'm saying that it's at 0 pixels on the left and 0 pixels on the top, which puts it initializes it right at this far corner right here. And then I'm just appending it onto the DOM right here. So, and this is jQuery right here. This is just saying that on document load, take this div, which we assigned right here, div ID WebGL container, and append it with this object right here, which is the stats.dom element. All right, and then our little render function right here that we're calling, this basically says that if we change these variables, these top 6, we're gonna re-render the scene with those new values. All right, next we have our animation. And all that's doing is it's updating our stats and calling the stats update function. It's calling this one, which is checking for our values, and the request animation animate function. Again, this is recursive, so basically it says request animation frame, calls the animate function, calls that, and so on. It goes through this whole thing and re-renders the entire scene. All right, and then the last thing I've added is just a simple resize function. This basically means jQuery on document load, which says that when I load the document, or when the document's ready, if the document's resized, okay, call this function. So all that says is that if I move anything around, like so, it's going to resize everything. So the screen width is equal to the window.innerWidth, which is a JavaScript function that just checks the inner size of the window and the inner height of the window, and it accesses those values and stores them, and then determines the correct aspect ratio using the camera.aspect feature. Okay, and then the camera again is updating the projection matrix according to those new values. All right, and then it sets the new size on it. Okay, so that's how that works. And then we're calling our init value, which was the function we defined up here, and then calling the animation function, which is what we determined up here. All right, and that basically creates this entire scene. Okay, so let's look and see what the spotlight does. All right, so again, we mentioned this earlier. We have our target, and this basically redefines our target position. So by assigning it to an object, if we were to say create an animation, we could have this light track the object in that animation. So simply put, all we would do is have that object in the scene move, and we would set the target value of it and make sure that that target is following along there. All right, next we have the intensity of light. Intensity refers to the strength of the light at its source. Okay. The distance on the light, default is 0, refers to how far the light will go. And you'll notice by changing it, the intensity is still incredibly bright over here, even if we have a short fall off. Okay, so you notice it's still, the intensity is still very, very high right here. All right, the angle is actually the angle of the light. And again, that's based in Euler radians. I've done 1.6. You don't really want to go above that, but that's half of pi right there, essentially as a value. I did that as a shortcut, just put in 1.6. Okay, we have exponent. And you can see, again, that relates to fall off of the light. This is our near and far clipping. Okay, so if I bring the far clipping in, you'll see it's going to clip the edges of that shadows. Now, one of the things I noticed with this demo is, let me raise the Y value on this so it goes up a little higher. Increase the far value on here. Okay. And I'm going to increase the distance on it. All right. Now the first thing I want you to see is the shading on this. You'll notice this is actually a fairly decent shadow that it's producing. However, if I increase the field of view, you'll notice that the shadow becomes less and less quality. Now I suspect this has to do with the fact that one light is generating a wide range of shadows, and they do this for resource management purposes. But what it leads me to believe is if you want to produce nice shadows, you probably need to have a fairly narrow field of view on your shadows. So you can see that is actually fairly, you can get it even more narrow than that and just have it only focus on one object, and you'll see that it really cleans this up. There you go. You see it produces a really nice shadow that way. Okay. Shadow bias. This refers to the actual position of the shadow itself. What's going to happen here is you'll notice that when I increase the shadow bias, it actually moves the shadow of this whole plane right here. In this case, because of the field of view, on it is narrow, it's only this one right here, but it actually changes the location of the shadow. I would recommend keeping this one for the most part at the default setting, which I believe is 0. Don't think you're really going to need to influence this one that much. All right, the final one is shadow darkness. This just increases the darkness of the shadow. Could allow you to have a light shadow on one light and then putting in a second light with a darker shadow. Then maybe using this to increase the field of view. So let's say we blur it out like that. And then we'll come up here and we're defaulting, actually, if I remember correctly, to 1028 on our shadow map. Let's go ahead and increase that to a larger number. Yeah, let's increase that to 2056. Okay, I'm going to save that. Refresh. My shadow bias down. Okay, you'll notice that our shadow slightly improved when we did that. What I'm going to do now is decrease the darkness of those and increase the field of view. You'll see that gives us a nice soft shadow. Might be able to get it a little bit better. Can in fact add I believe an anti-aliasing. Turn on anti-aliasing in the renderer. I'm going to hold off on that. I'll let you guys look into that in your own time. But that's another thing that we can do to soften these up even a little bit more. What you could do also is add a second light and maybe even bring these down even more so that they're just barely visible. Then add a second light that gives you a much darker light. And that should produce something very, very nice, or create a nice light effect in the scene. Anyways, that's it for the spotlight. I hope this kind of clears up any confusions you may have in regards to it. If you have any more questions, feel free to leave a comment in this video. I'm also going to provide a link to this actual file so you can have a look at that. And I hope you have a good day, and don't forget to subscribe. Thanks, guys.